Good morning, my dear students. Today I will teach you shear force bending moment. Let us start. What is shear force? Shear force is the algebraic sum of all the forces either in the left hand side or in the right hand side of a section. You see one beam in the diagram. I have taken one section XX. Now, shear force means that either at the left hand section of the XX or at the right hand side of the section XX, any one section, we should add all the forces, algebraically add all the forces, and that algebraic sum will give us the shear force. What is the sign convention for shear force? The sign convention in the shear force is that at the left hand side of the section, left up is positive, or at the right hand side, if the force is downwards, then it is positive. So we remember it like this way: left up, right down is positive. Let us now define what is bending moment. Bending moment is the algebraic sum of all the moments either at the left hand side or at the right hand side of the section. The sign convention for the bending moment is that in the left hand side, if the bending moment is clockwise, or in the right hand side, if the bending moment is anti-clockwise, then it is positive. We can tell that a sagging bending moment is also positive, because this type of sign convention, as we are discussing, this is generally applicable for simply supported beam. Simply supported gives sagging bending moment and it is considered as positive. Similarly, in case of a cantilever beam, cantilever gives a hogging bending moment and hence it is considered as negative. What is hogging bending moment? That at the left hand side of the section, the bending moment is anti-clockwise, and at the right hand side of the section, the bending moment is clockwise. Now I will discuss about few important formula and diagram you should remember for the different types of beam, simply supported beam and the cantilever beam. Let us start with the first example, simply supported beam. This is a simply supported beam of span L and a W Newton point load is acting at the mid span. You can see that it is acting at L by 2, L by 2. That is, it is centrally located point load W is acting in the beam. So the shear force diagram is like this. As you can see that SFD is like this way. Two opposite rectangles are formed and the bending moment diagram is a triangle, and the maximum value of the bending moment is given as WL by 4. I have put a star mark over here because this type of question is directly asked in the GATE, that find out the bending moment value for a simply supported beam with a point load at its center. And in this case, what is the maximum value of shear force? The maximum value of shear force is W by 2. Now let us see the second formula, that this is the simply supported beam of span L and uniformly distributed load of W Newton meter is acting on the beam. So the shear force diagram is opposite two triangles are formed, right angle triangles are formed. The maximum value of shear force is at the support. What is the value? WL by 2. And the bending moment diagram is a parabola with the maximum value at the center, and that is the value is WL square by 8. Here I have written one word P and circled it, so it means the shape of the BMD is a parabolic one. Let us take another example. This is a simply supported beam of span L. This is a triangular load, so it is starting from 0 and it is the maximum value is W Newton per meter. It is at the other end of the support. So what is the shear force diagram? The SFD looks like this way, that it is a parabolic one. The values at one support is WL by 6 and at the other support, that where the load is is maximum, that is W Newton per meter. So there the shear force value is WL by 3. So what is the maximum value of shear force in the case of this right angular triangular load? So the maximum value is WL by 3. What will be the BMD? BMD is a cubic parabola and with the maximum value is WL square by 9 root 3. So please remember this value, and also please note that in the previous case the BMD was in case of a UDL the BMD was a parabola, and in case of a triangular load the BMD is a cubic parabola. Let us now take example of for a cantilever beam. This is a cantilever beam. One end is fixed, the other end is free. Now W is the point load, it is acting at the free end. The cantilever beam is of length L. So what will be the shear force diagram? Shear force diagram will be a rectangle of height W, and the bending moment diagram is a right angle triangle with the maximum value of bending moment is WL. So at the fixed end, the maximum shear force as well as the maximum bending moment occurs. Let us take the next example. This is a cantilever beam of span L and it carries a UDL, uniformly distributed load of W Newton per meter. So in this case, the SFD is a right angle triangle with the maximum value of shear force at the fixed end, and the value is W into L. The BMD diagram is a parabolic one. The maximum value of bending moment is WL square by 2 at the fixed end. Let us take another example. This is a cantilever beam with a triangular load. The triangular it starts from 0 at the free end and it is increasing, and at the fixed end it becomes W Newton per meter. So the SFD looks like this with the it is a parabolic one. The maximum value of shear force is WL by 2 and it is at the fixed end. The BMD is a cubic parabola with the maximum value is WL square by 6. It is also at the fixed end. Let us now discuss few concepts of shear force and bending moment. First, I will tell you about the point of contraflexure. Point of contraflexure means the point where the bending moment changes its sign. That means it can change from positive to negative, from negative to positive, or means the changing the sign means it becomes 0. You can remember this like this way because the contraflexure, this flexure word means bending moment. So flexure meaning bending moment. So the point of contraflexure means where the bending moment changes its sign. Next is point of contra shear. The point of contra shear is the point where the shear force changes its sign. Now let us learn about the relationship between the rate of loading, shear force and the bending moment. Rate of loading is denoted as W, shear force as capital V and bending moment as capital M. So what is the relationship? W equal to dV by dx, that is the rate of loading is represented by the slope of the shear force diagram, and V, that is the shear force, is equal to dm by dx, that is the slope of the bending moment diagram. Now from here we can infer that if shear force equal to 0, that means dm by dx equal to 0, that is the first derivative is 0, that means from here we will get the maximum value of bending moment. Before starting of the numerical in my next video, please remember few points over here. So point to be noted, number 1, bending moment at the simply supported ends are 0. Number 2, bending moment at free end is 0. Free end means at the free end of the cantilever it can be the overhang part of the overhanging beam maybe. So anywhere if you see free end, the bending moment is 0. Number 3, bending moment is maximum at the fixed end of a cantilever. In case of a cantilever, where is the maximum bending moment? At the fixed end. Number 4, shear force is maximum at the simply supported ends of a simply supported beam. Let us see past year GATE question papers. The first question is, a simply supported beam of length L is carrying a centrally concentrated load P. The bending moment at the center of the beam will be The answer is PL by 4. Let us solve one past question. The point of contraflexure is the point where the option A, shear force changes its sign, option B, deflection is 0, option C, bending moment changes its sign, option D, torque is 0. So the correct answer is option C. The point of contraflexure is the point where the bending moment changes its sign.